Scorpio team is a part of off-road vehicle department within mechanical engineering faculty at Wrocław University of Technology. The team consists of 28 members who are divided into 4 teams responsible for different parts of the design. These include mechanical, electronic, software and science teams, all supervised by the management team. The team is supervised by Professor Piotr Dudziński from the department. This year's Scorpio project has a new PR team that manages sponsor relations and promotion. Also, a new cooperation within Faculty of Chemistry has been introduced to ensure high level of completion of science tasks. Mechanical design of Scorpio X is divided into separate, however cooperating units, each designed to address specific problems. The construction is made mostly of aluminum used in aviation and polyamide, light materials with good mechanical properties. The driving module is inspired by 4-wheel rocker bogie system that was modified for better performance. To ensure good surface adaptation, high damping tires made of Cordura fabric and filled with foam granulate were designed. The rover is 4-wheel drive with each wheel powered by separate BLDC 250 watts engine. By this, we achieved ability to overcome many obstacles such as erratic terrain, ditches and very steep slopes. All units, including the driving module, are controlled by Raspberry Pi, the onboard computer running Linux operating system. Each component is connected with the computer via CAN bus that ensures unfailing communication. Commands to and vision from the rover are transmitted via 900 MHz and 2.4 GHz frequency. The power management has been designed in a way that guarantees safe and most efficient usage of LiPo batteries. Mounting wheel control unit allows for each hub motor to be steered separately, which results in very accurate movement of the rover. The design stage of our project has been completed in January. As of now, the mechanical team's goal is to secure all the parts necessary to build the robot. Some parts are handmade or machined by drilling, welding and turning in our laboratory. The more complex parts will be made for us by the company Protocase. Electronic parts have been already made and are under testing using the previous version of Scorpio rover, the Scorpio N. All works are expected to be completed in late April. To complete the autonomous traversal task, a specific unit was developed consisting of GPS, accelerometer, gyroscope, and magnetometer. To ensure that the rover doesn't collide with any obstacles, another module with rangefinder, LiDAR light version 3, and ultrasound sensors was designed. In addition to that, Scorpio X also gathers and recognizes camera image to record gate markers on its route. To complete science tasks, Scorpio X has to collect samples of soil from the contest site. To do that, a drilling unit was designed which is capable of isolating required sample from any depth up to 8 cm. During drilling, soil is transported vertically through a sleeve and ejected from the rover. When desired depth is reached, the ledge is lowered on the sleeve so that the soil can be contained in a 3D printed box. Using onboard instrumentation, the probe with temperature and humidity sensors can measure both ground and surrounding parameters during the drilling process. To measure radiation, we've designed our own Geiger counter, and we are now developing software to allow us to incorporate spectrometer in the science task. Further chemical analysis is conducted in the base and will focus on detection of chemical elements and compounds that support life development. The robotic arm has been designed with the equipment servicing task in mind. The main adaptations to this task include 6 degrees of freedom that allow much wider range of motion and operating abilities. Magnetic encoders have been installed at each axle to ensure very accurate movement. Every undesired or unexpected movement is corrected by the motors or actuators. We have also applied inverse kinematic to improve the quality of movement and to facilitate the work of the operator. In terms of extreme delivery task, we've created an application that displays range of motion of the robotic arm and that allows us to program the movement. Also, previous problems with traveling salesman algorithm has been resolved, and now the best path for Scorpio X is quickly computed to ensure completion of extreme delivery task.